In this episode, we focus on a challenge that sounds like it belongs only to data specialists, but actually affects nearly everything an organization does: how information is structured so it can be protected, understood, and used reliably. Beginners often hear information architecture and think it means organizing files or designing a database, but in governance it is broader and more strategic than that. Information architecture, IA, is about defining how important information is described, related, stored, and shared across the enterprise so that security controls can be applied consistently, analytics can produce trustworthy insight, and operations can run without constant confusion. When information architecture is weak, security teams struggle to know what data exists and where, analytics teams spend more time cleaning data than learning from it, and operational teams build workarounds because systems do not align. When information architecture is strong, data becomes more governable because people can find it, trust it, protect it, and use it without reinventing definitions each time. The goal here is to understand what it means to define IA with these three outcomes in mind, and how a clear information architecture reduces risk and friction across the organization. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at CGEIT.me in the Bare Metal Study Guide series. Defining information architecture starts with defining information domains and key concepts, because you cannot govern what you cannot name clearly. An information domain is a major category of information that the enterprise cares about, such as customer information, employee information, financial information, product information, supplier information, and operational telemetry. Within each domain, key concepts need consistent definitions, like what counts as a customer, what counts as an account, what counts as a transaction, and what counts as a product version. Beginners might think definitions are trivial, but inconsistent definitions are one of the biggest causes of broken reporting, failed integrations, and policy confusion. When two systems use the same word to mean different things, security rules can be applied incorrectly, analytics results can disagree, and operations can waste time reconciling mismatched records. A strong IA defines a shared vocabulary so that when data moves across systems and teams, the meaning stays stable. This shared vocabulary is not about perfection. It is about enough consistency that governance can be applied without constant debate. Once the core domains and concepts are defined, the organization has a foundation for security classification, analytic models, and operational workflows that depend on those meanings. Another important piece is defining the relationships between key data elements, because security, analytics, and operations all depend on understanding how information connects. For example, a customer record might connect to orders, support tickets, subscriptions, and billing events, and each connection has implications. Security teams need to know which systems contain customer identifiers and which systems merely reference them, because that affects access controls and incident response. Analytics teams need to know whether records represent the same real-world entity, because otherwise they will double count or misinterpret trends. Operations teams need to know where the authoritative record is, because they must resolve issues quickly without guessing which system is correct. Defining relationships is a way of reducing ambiguity, and it becomes especially important as organizations add new services and channels. Beginners can picture this as a family tree of information, where you can understand what depends on what and where changes will have ripple effects. When relationships are documented and agreed upon, the enterprise reduces the chance of creating data islands that force manual reconciliation. Information architecture also includes deciding which sources of truth exist for key data, because without that decision, the organization drifts into duplication and inconsistency. A source of truth is the authoritative place where a specific type of data is mastered, meaning it is created and maintained there according to agreed rules. Other systems may copy or reference that data, but they should not silently redefine it. Beginners sometimes assume multiple copies are good because it feels safer, but multiple uncontrolled copies create conflict and make governance difficult. If an address is different in two places, which one is correct and who fixes it? If a customer status is different across systems, which one drives decisions and which one is outdated. A well-defined IA clarifies which data is mastered where and how other systems should consume it, which supports security by limiting where sensitive data must be protected at the highest level. It supports analytics by reducing disagreement between reports, and it supports operations by reducing time spent chasing the correct answer. This is one of the most practical ways IA improves day-to-day efficiency while also strengthening control. To support security specifically, information architecture must make it possible to apply consistent protection based on what the information is and how sensitive it is. That means defining data categories that security controls can hook into, such as personal data, financial data, health-related data, intellectual property, and operational secrets. It also means defining where sensitive data should live, how it should be shared, and what the minimum necessary exposure should be for systems that do not need the full detail. Security teams often struggle when data is everywhere without a clear structure, because it becomes hard to enforce least privilege and hard to respond when an incident happens. When IA is clear, a security team can more easily identify where sensitive data is processed, which systems should have tighter controls, and where logging and monitoring should be strongest. It also helps define data flow expectations, such as which systems may receive sensitive data and which should only receive tokens or references. Beginners can think of this like labeling boxes in a storage room, because if you know which boxes contain fragile items, you can handle and protect them appropriately. IA provides those labels and the rules for how boxes are moved, which turns security from guesswork into structured control. To support analytics, information architecture must prioritize data quality, consistency, and context, because analytics fails when data is incomplete, inconsistent, or misunderstood. Analytics teams need stable definitions, consistent identifiers, and reliable timestamps, and they need to understand how data was generated and transformed. When IA is weak, analytics becomes an endless cycle of cleaning and arguing about what numbers mean, which wastes time and undermines trust and insights. A strong IA supports analytics by standardizing key metrics and by ensuring that different systems represent the same entities consistently. It also supports the idea of lineage, meaning the ability to understand where data came from and how it has been modified, which matters when leaders ask why a dashboard changed. Beginners often think analytics is just making charts, but analytics is really about decision-making, and decision-making depends on reliable meaning. Information architecture creates a stable foundation so analytics results can be explained and defended, which is critical for governance because leaders must make trade-offs based on those results. When IA supports analytics, the enterprise spends less time debating the numbers and more time using them. To support operations, information architecture must make it easy for people and systems to do routine work without confusion and without constant exceptions. Operations includes everything from customer support and billing to internal workflows like onboarding employees and managing inventory. Operational success depends on systems sharing information smoothly and on staff being able to locate the right information quickly. When IA is unclear, operations often creates local workarounds, such as manual tracking sheets or separate tools, because they cannot trust enterprise systems to be consistent. Those workarounds increase risk and reduce efficiency, and they often create security issues because data may be copied into uncontrolled places. A strong IA supports operations by defining common data elements, consistent identifiers, and predictable data flows, so operational processes do not break when systems change. It also supports error handling and troubleshooting, because when records and relationships are clear, it is easier to locate where a problem originated. Beginners can think of operations like running a busy store, where you need a reliable inventory system and consistent product codes, or else you spend all day searching and correcting mistakes. Information architecture provides the structure that keeps operational work predictable. One important teaching point is that these three goals, security, analytics, and operations, can conflict if IA is not designed thoughtfully. Security may prefer restricting access as tightly as possible. Analytics may prefer broad access to data for exploration, and operations may prefer speed and convenience. If you design IA with only one of these in mind, you can accidentally harm the others. For example, if data is locked down without clear governance pathways, analytics and operations may build shadow copies, which reduces security. If analytics builds its own definitions and stores its own copies, operations may see conflicting information, which causes errors and undermines trust. If operations stores sensitive data in many places for convenience, security becomes harder and analytics becomes inconsistent. A well-defined IA helps balance these goals by clarifying what data exists, how it should be categorized, and what the approved sharing patterns are. It also allows the organization to apply differentiated controls, where sensitive data is protected strongly while still enabling analytics through controlled access and well-defined datasets. Beginners should hear that governance is about trade-offs, and IA is one of the places where trade-offs must be made explicit. Another practical element is ensuring the information architecture is usable, meaning it can be applied by real teams in real projects without endless interpretation. If IA is too theoretical, it will be ignored, and then it cannot support security, analytics, or operations. Usable IA includes clear definitions, clear ownership, and clear expectations for how new data elements should be introduced. It also includes guidance on avoiding duplication, on reusing existing data structures, and on aligning new initiatives to enterprise data models. Beginners may wonder how this stays current, and the answer is that IA must evolve as the enterprise evolves, but it should evolve through controlled decisions rather than through accidental drift. This is why governance bodies often maintain IA as a living reference that is reviewed when major initiatives are planned. When changes to IA are deliberate and visible, security teams can adjust controls, analytics teams can adjust models, and operations teams can adjust workflows without being surprised. The stability of IA does not come from never changing it, but from changing it intentionally. As we close, defining information architecture that supports security, analytics, and operations means building a shared structure for information that makes protection, insight, and daily work all easier and more consistent. It starts with clear information domains, shared definitions, and understood relationships, and it includes decisions about sources of truth and data flows that reduce duplication and confusion. It supports security by enabling consistent classification, least privilege, and predictable control points. It supports analytics by stabilizing meaning, improving quality, and making results explainable rather than debatable. It supports operations by reducing friction, enabling reliable workflows, and preventing workarounds that increase risk. For brand new learners, the takeaway is that information architecture is not a niche technical activity. It is a governance foundation that determines whether an organization can trust and control its data while still using it to move fast. When IA is defined with these outcomes in mind, data becomes an asset that can be governed, not a mess that must be tolerated. That is why this task matters and why it sits at the center of effective enterprise governance.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.